Hello friends, welcome to my Python Tkinter serial port programming tutorial. So in this tutorial, you will learn how to communicate with an Arduino using Python and Tkinter. This is a graphical user interface based program. So I will run the program right now. So in this tutorial, I will teach you how to create this program. So here we are using Python and Tkinter. To make the graphical user interface look really good, I'm using the ttkbootstrap theme extension. So now I have a Arduino connected to this particular PC. So you can go to device manager and see that we have the Arduino connected to the COM3 port. This particular port number will be different on your system. So here it is COM3. So I can just put the number here, COM3, and then I will send some data. So I'll send the letter A, capital letter. The Arduino will get that particular letter A and will echo it back. Now I'll press the transmit button and send the character A. So all the actions performed by this particular program will be displayed inside the logging window. So I'll press transmit. So you can see that the Arduino has sent back the letter A. So you can also see what is happening inside the code. We have opened the COM port. We have set the baud rate equal to 9600. And then we have sent the letter A. And it has sent back the letter from the Arduino. So you can use another letter, capital P. So the Arduino has echoed back the same letter. This is done by a switch statement that is running on the Arduino. So if you send any other data that is invalid data, it will just display that the data is invalid. So I'll just send C and the Arduino saying it's an invalid command because it's not defined inside the switch. Now here I'll give a brief description of what you're going to learn in this tutorial. This tutorial is aimed at both beginners and intermediate programmers who want to learn about Python and Tkinter and how to communicate with a connected serial port device on both Windows and Linux platforms. Here we will learn how to install Python, Tkinter, and the ttkbootstrap library on our Windows system. So ttkbootstrap is a theme extension for Tkinter that provides this beautiful, professional looking graphical user interface. Now we will also teach you how to talk with the Arduino or attached microcontroller boards like Atmega, PIC, or the RP2040. Now the software we are going to write it is cross-platform. This will work on Windows, Linux, and Mac. In this tutorial, I will be dealing only with the Windows specific parts. For Linux specific parts, I will be doing a separate video. So do subscribe and like our video so that we can produce more of these kinds of video. So we will not be using any Python threading or other complicated stuff. We want to make the whole thing quite simple. The whole Python code is available in a single file that can be downloaded from our GitHub. And we will also provide you line by line explanation in this particular video. In this tutorial, we'll be using the PySerial library. If you are new to the PySerial library, you can check out our serial port communication between PC and Arduino using PySerial tutorial. I'll provide the link in the description. You can also follow along with this particular tutorial. I will also explain the same thing in this tutorial also. We also have a website, that is this one, where we provide all the data regarding the tutorial. So you can find the whole thing written in a text format along with the source code. You can go to the source code and you can download the whole thing as a zip file from here. Or you can go to our GitHub if you want. Now I'll talk about the hardware connection, how the Arduino is connected to the PC. Before we do that, please do like and subscribe to our YouTube channel. That will help a lot. So we'll go back to the hardware connections. So this is how the whole thing will work. We have the Python serial port communication program, that is this one, that is running on the PC side. And we have an Arduino that is connected to the PC through the USB port. The program will send a character to Arduino and the Arduino will receive the character and then it will send it back. That is the basic gist. So you can connect the Arduino to the PC using the USB cable. So here is a more detailed breakdown of the connection. We have the code running on Windows 11 here and is connected to the Arduino using the USB cable. Inside the Arduino, there is a chip that will convert the USB to the serial. That is usually Atmega 32 or Atmega 16U4. Once the USB is converted to serial, it is sent to the microcontroller. That will be Atmega 328P. Now the code running on Atmega 328 will receive the data and will send it back using the TXD and RXD pins of the Atmega 328P. So this is a very simple explanation of how the data travels from the PC to the Atmega 328P microcontroller. Now let's say you want to interface a microcontroller. If you are an embedded developer, you need to do that. So here I have a generic microcontroller. It could be anything like 8051, Atmega 328P or a PIC. And I'm going to connect it to the PC. For that, we have to require something called as a USB to serial converter. So here I'm using the USB to serial converter that is manufactured by our company. So this one has an FT232RL chip right here and a Max 232 as well as the Max 484. That is for the RS232 and RS485. That we are not using it. I'm just telling you that one. When we use the Python program to send any information, it will go and it will be converted into serial using this particular chip. That is the FT232 and will be sent back to the microcontroller. So this is how you connect the PC to a microcontroller. So you can buy the RS232 converter, the USB to serial, RS485 and RS232 converter from our website. We also provide fully isolated USB to serial converter. This one is fully isolated and can be used for USB to RS232 or RS485 conversion. Now we have installed the Python interpreter. The Tkinter GUI library is installed by default, so you don't have to install it separately. The other two libraries that we have to install are the ttkbootstrap theme extension for Tkinter. That is the one that is going to provide all the graphical user interface. The other one is the PySerial library. This is for opening and closing the serial port of the Windows system. So we need to install these two libraries first before we start our programming. So you can use Python -m piplist to check the install libraries. So I'll check that one right now. So we don't have any ttkbootstrap. So we have to install the ttkbootstrap library. So you can type Python -m pip install ttkbootstrap. The next library we want to install is the PySerial library. So you can type PySerial here and then you can install them. So you can check whether the two libraries are installed by running the piplist command. That would be this one. So you can see PySerial is installed and ttkbootstrap is also installed. So now we can start the programming. Now there is another ID called as Thonny, which you can use if you want to. This thing comes with an interpreter built in, and you can also install ttkbootstrap using this particular IDE also. So I'll be using this particular IDE. You can download it from here for Windows. So it will come with its own Python installer, so you don't have to install the Python separately. So this is the IDE. You can go to Tools, Manage Packages, and from here you can see what all things are already installed on this particular one. So you can see PySerial is already installed on this one. So you can press install here if you want to. So this will install the ttkbootstrap library. So this is how you manage packages inside the Thonny IDE. So first we will discuss the different GUI elements that are used for building our serial communication program. So here we'll be using labels, which is provided by the ttkbootstrap.label class. You can find the YouTube tutorial also right here. Then we'll be using buttons for transmission, so which is done by ttkbootstrap.button. We also will be using drop-down list, which is called as Combobox in ttkbootstrap terminology. And we'll use a text entry box. This is for entering data into the program. We'll also use a text box with scroll bars, which is called as ScrolledText in the ttkbootstrap library. This is our program for serial port communication. We can see that we are using the entry box, that is this one, ttkbootstrap.entry, for entering the COM port number as well as the transmission data. We can also use that to display the received data. So these three functions are provided by the ttkbootstrap.entry class. Then we'll be using the combo box or the drop-down list, that is this one, and that is used for displaying the baud rate. You can pull it down and you can select the required baud rate. Then we have the button, that is the transmit data. When you press this button, it will send the data to the connected Arduino. So we also have a logging window which will show the different things that are happening inside the program. So for that we will be using the ttkbootstrap.scrollText class. So you can this is like a large text window with scroll bars. Now we'll create the window first. So we will just create a Python file and we'll call it tkinter-serial.py. You can save it in your disk. The first statement is the import statement. So you're importing the ttkbootstrap library as ttkb. Then we'll create a root, which is equal to ttkb.window. So you can also add the theme section here. You can write theme equal to whatever the name of the theme if you want. So the other one is the root.geometry. This describes the size of the window. You can give it any size. If you change the size here, it will make the window bigger or smaller. This is the width and this is the height of the window. This is the letter X. That is the format for giving the geometry dimensions. Now root.title, this gives the name of the window. So I will be writing the name as Python serial port communication. If you run this program, you can see it on the top of the window. This is the root.resizable. This method says that whether you can change the size of the window. I don't want to change the size of the window, so I have provided both 0 on the X and Y coordinate. So this window will not have a maximize button. And finally, the root.main loop. So if you run this program, it will create a symbol window. So you can go to the PowerShell, and I have the code here inside this particular folder. You can now run Python name of the code. So this will create a symbol window. Nothing is there. It's just a symbol window. So you can close this one. This is how you run it directly from the command line. So you can also use the IDE like Thonny. You can right click on this one and you can say open with Thonny. So this will open with the Thonny IDE. You can also create the file directly from here also using new and giving the name. So you can run it by run current script. So you can see that we can run the program. This is a much easier way to run the code if you don't want to use the command line. Now you can change the theme of the window. So I'm going to give it a theme name equal to superhero. This is a dark theme, so it will change the theme of the window. Now I have added a label to our window. So it will be named as serial port number. So this is for giving information about the serial port number that should be entered into our text box. So we will just run this code, and we are using the dot place method to place it exactly. X equal to 20 pixels and Y equal to 30 pixels. So you'll run this. This will be placed right here. Now we have to provide an entry box. So I'll be using the entry box to take in the COM number. Now we have created the entry box for our COM port number entry. So I have named it COM port underscore number underscore entry underscore box. So when you enter anything, we can get that information from this particular box. So I'll just run it. Now you can see there is a box here, and we can enter something like COM3 or COM4 or something like that. Then you can use the get method to get that information. Now we'll create the transmit button. So the name of the variable is transmit underscore data underscore button. So we'll be using the tkb.button text equal to transmit data. This is the text that will be on the transmit button. So we'll be using boot style. It is similar to theme. It will give it a reddish color. You can check that in the ttkbootstrap documentation. You can also use other colors like success, which will be a green color. And then we provide the command, which is the button handler. So when you click the button, this particular function will be called, and whatever information, whatever code is in that one, that will run. So we have not written the button handler, so we have to create that one. So we can go here. So when you click this particular button, the code will come here and it will run whatever it is written here. So if you want, you can get the information from the entry box by using .get method. So whatever is entered, it will be printed in the command line. So we have the transmit data button. So I will just write A here. So you can see from here, it equal to A. So you can also give full COM3 or COM7, depending upon the. I've written COM3 here, and I'll press the transmit data. So here we can see COM3. So most of our code will be inside this particular transmit data underscore button underscore handle. It will actually call another function which will do the reading and writing into the serial port. So now we will create the baud rate selection combo box. So for that, we have to create a list of standard baud rate. So we have 1200 up to this particular value. So we'll provide this list to the combo box, which will then show them in a drop down menu like that. So all this information are actually text. So when you're using when you're getting that information, you have to convert them back into the integers. So here we are creating the combo box, ttkbootstrap, and you have to provide the values. That is the list of values that will be displayed in the drop-down combo box. So we are giving this particular list, that is the standard baud rate list. So values equal to this particular list. So you can also configure one particular baud rate as the default value by using the .current method. So I'm giving it as 3. So it will be 0, that is 1200, 1, 2, and 3. So the default value will be 9600. So then we have to bind the combo box to a handler. So when you select any value, the handler will run, and you will know which particular value has been selected. You have to define the handler first. So the default value for this particular combo box is 9600. So if you don't do anything, this will be the one that will be on the selection. And if you can see the other one also, you can select particular one. When you select that particular one, this function will run and information will be given here. So I have replaced the print e with the .get command of the baud rate underscore combo variable. So it will display the selected baud rate right now. So I'll go here and I will take one as 1200. So 1200. So you can do 9600 if you want, like this one. Now we are going to create the entry box. So we need a way to take in the data that has to be transmitted to the Arduino. For that, we are going to create an entry box. So we'll name the entry box as transmit underscore data underscore button underscore entry box. And we are going to use the ttk.entry to create that particular entry box. Now, as you can see from here, there is a dot insert 0 and a space. So we want to clear the entry box. So we are going to use the dot insert method. And we are going to use the 0. 0 means that to insert in the first position. And we are using the blank space right here so that it will clear the data. So when this code runs, it will clear the data inside the entry box. So if you're running your program and again, there will be data from the previous entry. If you want, it can be cleared by using the dot insert. Then you have the usual dot place. So we'll place the entry box near the transmit button. So that's this one. And you will run this particular one. And now we can see that we have all the parameters required to open the serial port. We can get the serial port number from here, like this. And you can get the baud rate from here. And you can add the data. If you are sending A, that will be that one. And then you can just press transmit and the data can be sent. All the code should be inside the transmit data button handler. So we'll do it right here. So this is how it will work. We have the transmit data button here and the transmit data underscore button handler. So when you click this one, I will go here and call this particular function. That is the serial underscore Arduino underscore send underscore receive. So this is the function that will be doing all the major work. So inside this particular function, you will read the serial port number as I have shown you earlier. Then we'll open the serial port and then we'll set the read timeouts. So we'll be sending data and the Arduino will be sending it back. So we need to have the read timeouts here. Now when you open the serial port connection to the Arduino, the connected Arduino will get reset. Because when you open the serial port, some of the RTS and DTR lines of the serial port will get toggled. This will result in the Arduino getting reset. So you have to wait for 2 seconds so that the Arduino gets reset and goes back to its original state. Then you can write the data to the serial port. Or you can use the .write or the .write line methods. Then you wait for the Arduino to send back the data. Then you get that data using the .read method. So once you get that read method or the read line method, you can display the received data on this particular entry box. So we have not created that one. We'll create it soon. So this is the whole software architecture. The whole code is run by the transmit data. When you press this button, the whole thing starts. So if you want to change some part of our code, you should modify the code in this particular function. Now I have made some changes here. First thing is that we have to import the PySerial module. So we are calling the import serial here. This is the import serial. After that, I have created the serial underscore Arduino underscore send underscore receive function. That will be this one. And all the data has been, all the major functions are now done by this particular function. So inside the transmit button, we are calling this particular function. So when you click the transmit data, this will come here and this will call this particular function. So I'll explain how this particular function works. First, we are going to get the port number. That is the COM port number, which we'll be using to open the serial port. So we'll use the COM port number entry box dot get. This method will give the string corresponding to the port number. So it will be something like COM11, COM12 or something like that. You have to go into your device manager and check the COM port number of your Arduino. So then we get the baud rate. So these are the two parameters we require to open the serial port. So we will get it from the baud rate underscore combo dot get. This is the drop-down combo box. So when you use the get method, it will give the selected baud rate. So you have to select it first. By default, it will be 9600. If you want, you can print it. I'll print it. So this will make it much easier for you to understand. So I'll run it once more. So I'll enter the COM port here, COM11, and I can select it 4800. Then I click the transmit data. You can see the selected port is COM11 and the baud rate is 4800. Now we are getting an exception because this is not a correct COM port number. I just want to show you something. So you can close it. Now we are going to open the serial port here. So we'll create a serial port object. That will be this one. And then we'll try to open the serial port. Here we have serial.serial and we provide the port number, that is COM port number, and the baud rate. And I will also set the serial port object dot timeout. These are the read timeouts. So the system will wait for 3 seconds before it times out. That is equal to 3. Now this is under the try, except, else handler. This is for handling the exceptions. So in case your baud rate or the COM port number is wrong, the system will fail gracefully. So we will catch the serial.serial exception. So that is one of the exceptions generated by the serial port. It is provided by the PySerial library. So it will print an exception as occurred and give the details. So this is a graphical user interface program. I have decided to add a message box also. This is the message box. So we have to give the title. This is the title that serial exception has occurred, and we'll also display a message. So if you run this one and you give some, this is a wrong value, it won't work. So you'll get something like that. Could not open port COM11 file not. So you can close this particular one. So if you are successful, it will open the serial port object and then it will close the serial port object. So we have to put our code here, what we want to do here, whether we want to write information into the serial port or to read from here. All the data will be inside this particular else. So here. Now we will connect our Arduino. So you can go here, right click here and go for the device manager. And you can go here and find out under comps, ports COM and LPT. You can see that there is a serial devices connected to our device. So under COM and LPT, you can find that USB serial device COM3. That is the name of the Arduino that we are going to use. So that COM3 will be different in your system. So you have to go into the device manager and check the serial port number. Now I'll add that one right here. I will run the code. I'll provide this as COM3 and then press the transmit data. So you didn't get an error. It's because COM3 is a proper serial port. And you can see that port equal to COM3 and we get the details of the COM port that has been opened. You can see it is opened That means that it has printed out this particular one, and then it had closed the serial port. So you can see the serial port is open equal to true, name is com3, port rate is 9600, and other information. So this is how you open a serial port in Tkinter. Now this is a serial port communication program. So it involves two parties. One is the PC side and the other one is the Arduino side. So we are going to talk about the Arduino side right now. So we have to make a small program. So this is the program running on the Arduino side. So we define the baud rate using the serial.begin, and we set it as 9600. If you want to change the baud rate, you have to change it here and also on the Python side, that is the PC side. So inside there is a loop which is constantly running. So it waits for data coming from the PC to get the received data and store it inside the command, and then use a switch statement. So it will check whether the command is A. If it is command is equal to A, it will send the character A back using the serial.println. So it will be also sending a line, that is the new line character. That is important. You have to remember that it will be sending A as well as a new line character. Then if you're sending the capital letter B from the PC, it will echo the same character here. So if any other data that is not provided within the switch statement, it will just replay invalid command. So before running the code on the PC side, you have to download this particular code onto your Arduino. So I'll be using the Arduino Uno here. This particular code is available on our GitHub, so you can just download it from there. Now we need a way to display the received data. You can send the transmit data by using this particular entry box. So we'll be using another entry box to display the received data. You can also use a label, but I'm going to use the entry box. So we are going to create the received data entry box. So we'll go inside the main loop. So we have created this one, the received underscore data, which is an entry box. So we are placing it right here. We are also giving a label. So we are using text equal to receive data, and the boot style is equal to success. So that is, the text will be in the green color. And we'll also place the label at this particular place. So if I run this one, it will show a received data entry box. So all the data that is received from the Arduino will be displayed in this particular box. Now we are back in the serial underscore Arduino underscore send receive function. So inside the else, we have added a few more lines. So we want to get the data that has been entered into the transmit data button entry box. So we use the get method of that particular variable and then store that data in the data to be transmitted variable. So this would be a string. So PySerial does not allow you to transmit a string. So you have to convert them into a byte array. So we'll be using the byte array function, and then you'll encode it using the UTF-8. So it will be an array of 8-bit ASCII characters that will be sent from the PC to the Arduino. Now we can send that particular data using the .write method. So we are using a small delay here, time.sleep for 2 seconds. So this will give enough time for the Arduino to get reset and go back to its normal operating mode. After which we will be using the serial port.write method, and we will send the data to be transmitted. This should be a byte array, not a string. That's why we are using this particular function to convert the string to a byte array. Then you can close the serial port. So this will be received by the code running on the Arduino. You also have to provide the import time also. Now, once the data is received by the Arduino, it will send back a response. So we have to get that particular response from the serial port. So we'll use the readline function. So this is the readline function. So it will read all the data till it encounters a new line character, that is the \n. So on the Arduino side, we'll be sending a character using the .println, this one, so that it will be sending the character A or any other character along with a new line character. So if you're using print, it won't work because the other one is waiting for the new line character. So you have to use the println here. So once the data is received, it is stored here, and we have to decode it from byte array to a string. If you give it directly to the Tkinter GUI elements, it will result in an error. So here we are receiving the value, that is this one, and you are decoding it back to the string. And we are also using the dot strip function. So we'll be removing all the \r and \n. So it will be much cleaner and you can display it. So if you want, I can show you. This will be before, then this will be after. So I'll run the code. So I'll provide the com. So I'll use the default. I'll send A and I'll send transmit. So we have sent the letter A and we have received back the letter A. This is the received data. So as you can see, it's a byte array, and you can see that there is a \r and a \n character. So that is directly from the read line. That will be this particular one. Then we are cleaning it out using this particular line. And as you can see, you can just see the A. This can be directly given to the received data entry text box. So it can be displayed on the screen. Now we have to display this data on the other one, the graphical user interface. So we have to use so we'll use the name of the GUI, that is this one, that is the name of the entry box for displaying the received data. And then we will use the insert function to insert the received data. 0 is to say that we are inserting in the beginning. So once you run this code, the data will be inserted into the GUI entry box. You also want to clear this particular entry box every time this particular function runs, so that we can remove the previously received data. So this is for deleting the old values. So we will use the .delete function and you will delete from the end. Now if you want, you can add a logging system using a ScrolledText box, and you can insert all the logging values inside that one. So you'll get instead of looking at the shell, you can just display all this information inside the graphical user interface itself. So it will be much more cleaner. Now I have included a logging window using the ScrolledText widget from the ttkbootstrap library. So this is the logging window where you can display a lot of text. So to create the ScrolledText, you have to import the required libraries first. So from ttkbootstrap, you have to import the ScrolledText. So you can create the ScrolledText box using this particular function. So you can use a ScrolledText, then you can provide the height and the width. You can also provide wrap. That means that the text will wrap around the edges of the text box. So to add the data into this particular ScrolledText, you have to use the insert function. So you can just provide the insert function like this one, log data, that is the name of the ScrolledText. Then you can add to insert tk.ent hello logging. This is the information that we are going to insert into the text box. So you can see hello logging is here. So you can also insert what we want, like information about the comport status, etc. So instead of using this one, you can go here, put it this one here, and you can just copy this one. Now we can run the code. We'll give it com1, so com3, and we'll press transmit data. So you can see that port equal to com3 and baud rate equal to 9600 are being displayed on this particular text box. So you can add the \n, so they are all kept below. So this is how you insert data into the ScrolledText box. Now I hope you liked our small tutorial on using the Python Tkinter to create a serial communication program. So if you like our tutorial, do like, do subscribe, and if you have any doubts, do write that out in the comment section. You can download the code from our GitHub, and if there is any issues, I will try to reply to your comments. So thank you for listening to our small tutorial.